Hello dear friends of Mwalimu Theophil Academy, I welcome you in this session. Here we have an electrical circuit. We are asked to use the details in the circuit above to calculate A. Ammeter reading, B. The electric current and the potential difference PD across each resistor. Now, let's start. When you look well this circuit, you will find that we have some resistors which are in parallel and some which are in series. For example, here, this setting at this part, we have three resistors. This one, this, and this. Also, we have a second setup of this one. This part contains three resistors which are also in parallel, meaning a 16 ohm resistor, 14 ohm resistor, and 12 ohm resistor are in parallel. When these two parallel systems, when these two systems of resistors which are in parallel, when each system, the resistors are combined, you find that we get a single resistor in each part, and each resulting single resistor becomes in series with the 8 ohm resistor and 10 ohm resistor. Something to note is that when you are dealing with the dividing potential difference and electric current in the given resistors in a given circuit, something to start with, you have to combine first all of those resistors which are in parallel so that you get a single resistor representing all the resistors in parallel. Now we are going to start by combining the resistors, this one 2 ohms, 4 ohm, and 6 ohm resistor, and the 16, 14, 12 ohm resistor to make a single resistor here and a single resistor here, in which each resistor resulting from these two parallel systems becomes in series with 8 ohm resistor and 10 ohm resistor. Now let's start combining these resistors which are in parallel connection. Let's start with this part. Now, we have this 2 ohm resistor which is in parallel with these two resistors that are in series, 4 ohm resistor and this 6 ohm resistor. Something to note is that when you have two resistors in series, their effective resistance, meaning total resistance, is obtained by summing up the given resistances of the resistors present. Now, the sum of 4 ohm and 6 ohm resistors is equal to 10. We take just 4 plus 6 as they are in series. So for these three, let's start combining these two which are in series. When resistors are in series, simply we sum up the given resistances of the particular resistors. Now let's see solution. Let's take R total resistance 1, R total 1, meaning that the sum of the two resistors, 4 ohm and 6 ohm, where is there in series we add is 4 ohm plus 6 ohm. We get is equal to 10 ohm. It means that a resistor representing the two is the one having 10 ohm. Now, that 10 ohm resistor is going to be parallel with the 2 ohm resistor. So, the sum of resistances for the resistors which are in parallel, we use this formula. Now we say that 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus dash plus 1 over Rn, where n is any given number of resistors. Maybe you have 10 resistors, 10, 12 resistors, 13 resistors, and so on. Now, here we are going to have only 2 resistors. Now, let's take their sum is R total 2. Now, we're going to have 1 over R total 2 will be equal to 1 over 2 plus 1 over 10. Remember, we have already combined 4 and 6 to be 10. Here, let's compute the value of this R total 2. 1 over R total 2 is equal to the LCM of 2 and 10 is 10. 10 divided by 2, we get 5. 5 times 1, 5. Plus 10 divided by 10, 1. 1 times 1, 1. Now we are going to have 1 over R total 2 is equal to 60 divided by 10. Let's cross multiplication where we are going to have 60 times R total 2 is equal to 1 times 10, which is 10. Now we divide by 60 to get R total 2. Now R total 2 will be 10 divided by 60. Now when we compute this, 10 divided by 6 we get 1.66, which is approximately 1.67. This becomes 1.67 ohm. It means that a resistor having 1.67 ohm will replace a 2 ohm resistor, 4 ohm resistor, and 6 ohm resistors. Now, instead of including these 3 resistors, we are going to use a single resistor having a resistance of 1.67. After that, we are through with this first parallel system. Now let's shift it to a second parallel system, which contains 16 ohm resistor, 14 ohm resistor, and the 12 ohm resistor. As we have said before, that the effective resistance for the resistors which are in parallel, we use this formula that 1 over total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus dash plus 1 over Rn. Maybe let's call this total resistance obtained now B R total 3 is a third time we calculate total resistances. Now we may say that 1 over R total 3 is equal to 1 over 16 plus 1 divided by 14 plus 1 divided by 12. 1 over R total 3 will be equal to, now let's find out the LCM of 16, 14, and 12. 16, 14, and 12. By 2, 8, by 2, 7, by 2, 6. By 2, 4, by 2, 7, by 2, 3. By 2, 2, by 2, 7, by 2, 3. By 2, 1, 7, 3. By 3, 1, 7, 1. By 7, 1, 1, 1. Now LCM is equal to, or LCM will be equal to 2 raised to 1, 2, 3, 4 times 3 times 7, which is equal to, let's compute this LCM. We have 2 raised to 4. We have 2 raised to 4 times 3 times 7. We get 336. 336. Now 336 is our LCM. 336 is our LCM. Now 336 divided by 16. 336 divided by 16. Here we get 21. 21 times 1 is 21. We add 336 divided by 14. Here we get 24. 24 times 1, we get 24. We add 336 divided by 12. 336 divided by 12. Here we get 28. 28 times 1, we get 28. Now when we sum up the numerator, we'll find 28 plus 24 plus 21. The answer is equal to 73. The answer is equal to 73 divided by 336. So we're going to have 1 over R total 3 is equal to 73 divided by 336. Now we cross multiplication. So we have 73 times R total 3 is equal to 1 times 336. 73 times R total 3 will be equal to 336. To get R total 3, we divide by 73 both sides. 73. Now we have R total 3 will be equal to, R total 3 will be equal to, when we take 336 divided by 73, we are going to have 4.603 is equal to 4.603 ohms. This means that a resistor having a resistance of 4.603 ohm will represent the three resistors, meaning a 16 ohm resistor, 14 ohm resistor, and 12 ohm resistor. So instead of drawing these three resistors, we are going to use a single resistor having 4.603 ohm. After that, let us see a new circuit row after we've combined all those resistors which are in parallel. Now a new circuit row will look as follows. This is our new circuit row. When you look across this circuit, you find that the three resistors, 2 ohm, 4 ohm, and 6 ohm resistors are already replaced by 1.67 ohm, as it was the obtained effective resistance for the three. And again, 16 ohm resistor, 14 ohm resistor, and 12 ohm resistors are already replaced by 4.603 ohm, as it is the effective resistance for these parallel resistors obtained in the previous calculation. Now, when you look at this new circuit row, you will notice that all the present resistors, 1.67 ohm, 8 ohm, 10 ohm resistor, and 4.603 ohm resistor, all are now in series. So we are able now to calculate the effective resistance for these resistors when they are in series. As you said before that, for the effective resistance, if the resistors given are in series, we just add the present resistances. Now we say that R total is equal to R1 plus R2 plus R3 plus dash plus Rn, provided that the resistors are in series. In this circuit we have 4 resistors, this one, this, 4 resistors. Now let's call it R total C. R total C meaning that total resistance for the circuit, meaning the whole circuit is, now these are the resistors for the whole circuit. So we are going to have R1, which is 1.67 ohm, plus R2, which is 8 ohm, plus R3, which is 10 ohm, plus R4, which is 4.603 ohm. Now let's compute this. We're going to have 1.67 plus 8 plus 10 plus 4.603. We're going to have 24.273 ohm. This is the total resistance for the whole circuit. Now, as we have already obtained the total resistance for the whole circuit, and we already have the EMF from the source, we are in the position now of calculating the ammeter reading, which is the total current of the circuit. As you find that ammeter is in series with the all components connected in this circuit. Now part A. We're going to apply Ohm's law. From Ohm's law, we know V is equal to IR, meaning that potential difference in volts is equal to current, electric current times resistance. Now, the voltage used is the total voltage, which is V total, meaning that total voltage or total potential difference will be equal to total current I total times total resistance, which is R total, meaning that total resistance of the circuit is obtained 24.273 ohm. Now, to get total current, which is the circuit current, will be equal to V total, Vt, divided by RT. This will be equal to total voltage, meaning that EMF given of the cell, or meaning that the EMF will be 30 volts divided by R total, total resistance of the circuit, which is 24.273 ohm. Now, let's compute this. We have 30 divided by 24.273. We obtain 1.24. Obtain 1.24 ampere. This is the ammeter reading, 1.24 ampere. So ammeter will read the current of 1.24. After that, we are going to calculate the potential difference in current in each resistor. Here, we are going to start with the electric current. And you have to note that the electric current for the resistors in series is the same and is equal to the total electric current in the particular series connection of resistors under consideration. It means the current flowing through 1.67 ohm resistor, 8 ohm resistor, 10 ohm resistor, and 4.603 ohm resistor is the same and is equal to the total current in all these series resistors under consideration. It means the current in each of the 4 resistors mentioned here is equal to 1.24 ampere, which is the circuit current. Now we are through with the current in 8 ohm resistor and 10 ohm resistor. These 8 ohm resistor and 10 ohm resistor they are still the same as in the original circuit. It means that the current flowing through 10 ohm resistor is 1.24, in 8 ohm resistor is 1.24. So it means that the current in 8 ohm resistor will also be 1.24 ampere. At the same time, the current also in 10 ohm resistor I10 will be equal to 1.24 ampere. What about the potential difference? The potential difference across 8 ohm resistor is going to be obtained from Ohm's law, the same in 10 ohm resistor, that V is equal to IR. So the voltage in 8 ohm resistor V8 will be equal to I8 times R8, whereby I8, its current is 1.24 times its resistance, which is 8. Now we complete this and we have 1.24 times 8. The answer is 9.92. 9.92 volts. What about voltage in a 10 ohm resistor V10? It will be the same. Its current I times R8, which is 10. Its resistance is 10. Now, when you complete this, you get 12.40 volts. So we are through with the current and the potential difference in 8 ohm resistor and 10 ohm resistor. Let's shift to these two parallel systems by starting with this one. This 16 ohm resistor, 14 ohm resistor, and 12 ohm resistor, whereby the single resistor representing them is the one having 4.603 ohm in this new circuit lock. From Ohm's law, we know that V is equal to IR. Now, the total voltage for these 3 resistors represented by this single resistor 4.603 will be equal to the total current for this, which is 1.24 ampere, times total resistance, which is 4.603 ohm. Remember, I have used the current of 1.24 ampere as this resistor is in series with the remaining 1.67, 8, and 10, so they carry the same amount of electric current, which is the total current in this series system. And remember, we have obtained it to be 1.24. Now, let's compute this. When we compute this, we have 1.24 times 4.603. We get 5.71. 5.71 volts. Now this is our potential difference for this resistor, which represent these 3. Remember, for the resistors in parallel, they have the same potential difference and is equal to the total potential difference for that particular parallel system. It means that 5.71 is the potential difference for 12, 14, and 16 ohm resistors. Now we say that V12 will be equal to 5.71 volts. The same V14 will be equal to 5.71 volts, and volts for 16 ohm resistor V16 will also be 5.71 volts. Now we are through for the potential difference in 12, 14, and 16 ohm resistor. What about their currents? As usual, we apply Ohm's law. V is equal to IR, so current will be equal to V divided by R. Now, the current in 12 ohm resistor will be equal to its voltage, which is 5.71 V divided by its resistance, which is 12 ohm. Now this will give, we have 5.71 divided by 12, we get 0.46 ampere. This is I12, the current in 12 ohm resistor. What about the current in 14 ohm resistor? The same, will be equal to its volts, which is 5.71 divided by its resistance, which is 12 ohm, which is 14 ohm, divided by its resistance, which is 14 ohm. Now this will give us 5.71 divided by 14. You get 0.41 ampere. Now, this is the current in a 14 ohm resistor. What about the current in 16 ohm resistor? As usual, current in 16 ohm resistor I16 will be equal to its potential difference, which is 5.71 volts, divided by its resistance, which is equal to 16 ohm. Now this will give us, let's compute again. We have 5.71 divided by 16. We have 0.36 ampere. Now this is the current flowing in the 16 ohm resistor. So we are through with the potential difference in current in these three resistors, 12, 14, and 16 ohm resistor. Let's shift to the last parallel system, which is a system containing 2, 4, and 6 ohm resistors. The same will apply Ohm's law. V is equal to IR, as these three resistors are represented by a single resistor of 1.67 ohm. Again, we start by calculating the total potential difference for these three by using their effective resistance. As usual, their total current is 1.24 ampere. As it is in series in this new circuit rock, we multiply by total resistance, which is 1.67 ohm. Then let's compute this. On computing, we have 1.24 times 1.67. After computing, we get 2.0708 volts. Now this is our potential difference for all these three resistors. Now, after we have obtained the potential difference for the combined three resistors, we know that when the resistors are in parallel, the potential difference across each resistor is the same. It means that in 2 ohm resistor, the potential difference dropping in it is 2.0708 volts. At the same time, when you combine these 4 and 2 to make 10, the potential difference across a 10 ohm resistor will be equal to 2.0708. So, starting with the 2 ohm resistor, it means that V2, its potential difference will be equal to 2.0708 volts. What about its current? Its current I, which is I2, will be equal to its voltage V2 divided by its resistance R2, which will be equal to its voltage. We've already said that it is 2.0708 volts divided by its resistance, which is 2 ohm. Now this will bring us this one divided by 2, we get 1.0354 ampere. Now the current in 2 ohm resistor is 1.0354 ampere, while its potential difference is 2.0708 volts. What about 4 and 6? Now let's see the current and the voltage in 4 ohm resistor and 6 ohm resistor. We have this 4 ohm resistor and 6 ohm resistor. 4 ohm and 6 ohm. These are in series. As previously we said that their total resistance, it was RT1, was equal to 4 plus 6, and we obtained it to be 10 ohm. 10 ohm. Remember, when the resistors are in series, they carry the same amount of current and is equal to the total current in that series system under consideration. But after combining this to be a single resistor, it became in parallel with this one. So the potential difference across each of the parallel resistors is the same. It means that these two, the potential difference across them is 2.0708. Now what about their total current? We say that current is equal to voltage divided by resistance. Now it will be equal to 2.0708 divided by their resistance, which is 10 ohm. 2.0708 divided by 10, you get is equal to 0.20708 ampere. So it means the electric current flowing through a 4 ohm resistor and 6 ohm resistor is 0.20708, as when the resistors are in series, they carry the same amount of current and is equal to the total current in that series system. It means I4 is equal to I6 and is equal to 0.20708 ampere. So we are through with the current. After that, let's calculate the potential difference across a 4 ohm resistor and 6 ohm resistor. As you said that the potential difference V is equal to IR. Now V4, the potential difference across a 4 ohm resistor, will be equal to its current, which is 0.20708 ampere, times its resistance, which is 4 ohm. This will give us, let's compute, 0.20708 times 4. We get 0.82832 volts. This is the potential difference across a 4 ohm resistor. What about the potential difference across a 6 ohm resistor? V6 again will be equal to I6 times R6, which will be equal to the same current, which is 0.20708 ampere, times the resistance, which is 6 ohm. This will give us 0.20708 times 6. We have 1.24248 volts. So 1.24248 volts will be the potential difference across a 6 ohm resistor. Now we are through with the task of finding ammeter reading and the electric current and the potential difference across each resistor. I hope you have enjoyed the lesson. If you have not already subscribed to our channel, make sure that you subscribe so as to get updates whenever I upload any video in this YouTube channel of Mwalimu Theophil Academy. Thank you. Have a nice moment. Bye.